In this video, we're going to explore how to convert from mass or grams of A to moles of B, where A is one substance and B is another substance. This problem, if we look at our diagram, our stoichiometry map, we're growing from mass of A to moles of B, meaning that we're going to need one quantity which is given, which is the mass of A, and we're going to need two conversion factors to get there. We're going to need the molar mass of A, and we're going to need the molar ratio of A to B according to the balanced chemical equation. So the basic setup of this problem is going to be X grams of A divided by 1. And in this step, we need the molar mass of A expressed in X grams of A per 1 mole of A. And where my third setup is going to be my molar ratio of A to B that we get from the balanced chemical equation, where we have X moles of A over Y moles of B. Everything is going to cancel out. Grams of A with grams of A, moles of A with moles of A, and we're going to get our target unit, which is moles of B. So let's get at it. This is where it gets a little bit complicated. We're given a chemical equation. This is a combustion reaction. Propane reacting with oxygen to produce carbon dioxide, water, and heat. So as with any other combustion, let's start off by balancing the carbon. So we have 3 carbons here, 1 here. I'm going to add a 3. Then we balance our hydrogen. There's 8 over here, and over here there's 2. So I'm going to add a 4. And finally, let's do our oxygen count. 4 times 1 is 4. 3 times 2 is 6. So we have 10 oxygen atoms over here. This means we have to add a 5 at the oxygen, and now we have our ratio. So tip number 1 is always balance your reaction and make sure that's right. Otherwise, the rest of the problem is ruined. Next up is how many moles of oxygen are needed to obtain 600 grams of H2O. So our substances are water and oxygen is how many, so this is where we're headed. So my first setup is, of course, I'm going to write 600 grams of water, which is my given, over 1. My next factor is the molar mass of water, which we calculate using our periodic table, and we know it's 18.01 grams of water in 1 mole of water. And my last factor is the molar ratio, where we have moles of water, and we want to convert to moles of oxygen. So once again, where do we get these numbers from that are missing? We get them from the balanced chemical equation. So in this case, water is accompanied by a 4 coefficient, so we write it down right here. Oxygen is accompanied by a 5 coefficient, which we write over here. We make sure the setup is correct. Grams of water cancels out, moles of water cancels out, and we're going to get how many moles of oxygen if we punch this into our calculator properly. So we multiply everything on the top, 600 times 5, divided by everything on the bottom, multiply, which is 18.01 times 4. And my answer, rounded up to 2 decimals, is 41.64 moles of oxygen is the answer. So we would need 41.64 moles of oxygen in order to obtain 600 grams of water. Let's use the same reaction for another problem. We already balanced it. We're sure this is correct. So again, our question is how many moles of carbon dioxide are produced from combusting 850 grams of propane. So don't be worried about the words in the word problem. Just try to understand what is being given and where we're headed to. So in this case, what we're being given is 850 grams of propane, which is this compound C3H8 over 1. And then we need the molar mass of propane. So grams of C3H8 over 1 mole of C3H8. I'm going to go ahead and complete the rest of the conversion factor so that we just have to do one step at the end and I'm not losing track. We want to cancel out moles of propane, and we want to convert to moles of carbon dioxide. Where do we get these numbers from? We get them from the balanced chemical equation, and we know that 3 is a coefficient for carbon dioxide, and we know that there's an implicit 1 over here accompanying propane. So 3 over 1. The last step to this is we're going to calculate the molar mass of propane, where we have 3 carbon atoms times 12.01, which is the atomic mass, plus 8 hydrogen atoms, each one weighing 1.01. So my molar mass for carbon dioxide is 44.11. That's what I got on the calculator. And then once again, we multiply everything on the top and we divide it by everything on the bottom multiplied. This should be easy because there's a lot of ones. So I say 850 times 3 divided by 44.11, because these ones, we don't need to punch them into the calculator. And after everything cancels out, grams of propane, moles of propane. Our surviving unit is moles of carbon dioxide, and my answer rounded to 2 decimals is 57.81 moles of CO2 are produced from combusting 850 grams of propane.